Welcome to Arduino Made Easy, Lesson 7. Today we're going to talk about IR sensors and how to trip our grade crossing flashing lights like we did with the ambient light sensors. But this one's going to be a little bit more easier. So let's get going with this right now. I'm Tom Kovichak, and this is Tom's Trains and Things. This channel was created to help other modelers who are in need of guidance in pursuing their dream of building a model railroad. And if you like to light up and animate your model railroad, you're going to want to watch this series of Arduino Made Easy because Arduino is easy to begin with, but I'm going to make it a little bit easier by explaining the steps for the code on there. If you're not familiar with coding, or if you're not familiar with electronics, this is for you. So, but before we get started with this, I wanted to show you what it's going to be looking like. But before we do that, we're going to have to weld these things on here. But here goes the LED. I got to weld the lead on there because it came apart on me. I'll do this one over here. This is another project I'm working on, a welder's arc. And if you don't recognize this right here, this is one of the lights that I took off of something that I got at Michael's. So we'll take a look at this on another video, but that is a welder's arc. So that's the magic of Arduino. You could do anything that you want in Arduino with code. So that's why I'm doing this. That's why I'm making it a little bit easier for you to be able to code so you could automate and light up your model railroad to make it look lifelike. So if you would like to see more videos like this on model railroading and Arduino, go ahead and hit that subscribe button. And while you're at it, ding that bell so you can be notified whenever I have a new video coming out. And check out my playlists. I have them categorized so you could find them easily on any subject that you would like to find. So let's get going with this right now. Before we tear this apart and start over, let's take a look at what it's supposed to do. So as you can remember with the ambient light sensors, we had one on each side of the grade crossing, but on this one here, I moved these IR sensors off to one side just because we're putting them in different pins and it's easier over here and then having the flashing lights over here. But anyway, we come over top of the sensor and that starts our flashing lights at the grade crossing. Now as the locomotive and all the rolling stock go through there, the grade crossing will continue to flash, and we come with our locomotive and cars on the other side, and as soon as they clear, the flashing lights will stop after a second or two. So that's what we're working on today, and that's what it's going to look like. Now it's time to tear it apart and start from scratch. I keep the power leads on there, but we have 4 jumper wires. We have 2 resistors, 330 ohm. We have 2 LEDs, and we have 2 IR sensors. Now these are normally high, so whenever there is nothing blocking the sensor, it will read high, and then when something goes over it, it will read low. So we have to keep that in mind in our sketch. If you're wondering why I have the code for low in there, you'll see it in a few minutes. In this sketch, we have a lot to declare before we even get started, so let's start off with that. You can see that I put the explanation up in here at the top in the header. So let's start off with the 2 sensors. So we're going to do integer. Yes. How do you spell sensor? Sensor 1 equal, we're putting that on pin 5. And then we'll go sensor 2 equal pin 6. How's that? Now we'll do the LEDs. LED 1, and we're putting the first one on pin 10, and LED 2 we're putting on pin 11, and then we're going to do entering sensor and leaving sensor. So and we're just going to start off with 5 and 6 on these. Entering sensor equal 6. All right, now what we have to do is, once we determine what the sensors are, we have to say, okay, now we want to determine when this thing started. So we're going to do a sequence started. So that's going to be an integer also. And that one is just going to be a 0. Now, after the sequence started, we're going to do the same thing that we did on the other one with flash state, flash time, and flash interval. Interval. So, flash state. So that's going to be an integer. Flash state, and then this is all going to be zeros. Okay, flash state, long time, and flash interval. Okay, 0, and what else do we have? And sensor count, we're going to be doing one of those I equal 1 that I showed you in another video. So that's going to be a integer. Sensor count is going to start off as a 0. So that's all we have to put in that section right there. And let's see, we'll clean this up a little bit, and let's see if I made any mistakes in here so far before we get any further with this. So everything looks good so far. Now we're going to go down into the setup. So we'll just get rid of this line right here. Okay, now void setup. So what we have to do, we have to do pin mode for the sensors and the LEDs. So let's do it this way. All right, we'll come over here so you can see what is going on right there, and we'll come down one line and we'll go pin mode, and sensor 1 is input. Sensor 2 is input. Then LED. LED 1 is an output. And then pin mode LED 2 is an output also. Okay, what else do we need? All right, so what we want to do, we want to digital write both the LEDs, starting them off as low. So we'll go LED, LED 1, low, and digital right, LED 2, low, and a semicolon, and one more thing. We want to do flash time like we did in the last one, equal milliseconds. And that is all we need in the setup. So now all we got to do is go into the loop. So let me put a couple extra lines in here on the loop so we have some room to work with. We're going to start off with an if statement. So what we want to do is this stuff, and I'm going to have to, I just looked down and I'm going to have to hook it up before we do anything on it. But anyway, what we want to do is we want the sensor to sit there and wait for something to happen. Now we got two sensors. We got, and like we did on the last one, we got east and west. But this one, we're going to name them entering sensor and leaving sensor. Whatever sensor gets covered first, that's going to be the entering sensor, and the other one will automatically be named the leaving sensor. So no matter which direction we're coming from, that's going to happen. If we come from this direction, this one's going to be the entering and this one's going to be the leaving. If we come from this direction, this one's going to be the entering and this is going to be the leaving, and that's what we're going to determine in these if statements. So what we have to do before we do anything is hook everything up. You'll notice that these IR sensors have 3 pins on it. There's a little potentiometer on there, and there's a little resistor on there. So we don't need to put any resistors in the circuit if you have this type of IR resistor that's on a board. So the first 2 pins on here go to, and as you can see on here, go to our plus and our negative, and then the next one goes to our pin that we want to read from. So let's make sure that we get this in the right spot. We'll put this one here. We'll put this one here. I want to make sure that I'm not fouling the wires right there. I'll put that one up here. And as you can see, whenever we have power on it, you get the right indication, and then whenever it's covered, you get the second LED that lights up. Okay, so those are going to be on pins 5 and 6. So we're going to use the white and the blue here. So we're going to come over to this one right here, the next one, and we're going to go to 5. And if my hand's getting away, I apologize. 0, 1, 2, 3, 4, 5. Right there. And this one comes over to, yeah, let me move this one back out a little, just one more row. So we have some room there. And this one will go on pin number 6, the next one down. All right, we got the 2 sensors on there. Now we're going to put the 2 LEDs on there. So what we want to do is I'm going to put it right here. And we'll put another one right over here on this side. Now it really doesn't matter which which numbers that they go in. Just make sure that you keep everything all in line so everything's in the same row. And we'll put our LEDs back up through here. And then we are on, what numbers are we on here? 10 and 11. So we'll go 10. Oops. Okay, this one is okay. 8, 9, 10. And this is 11. Okay, I gotta stop this. Okay. Now, once I had the pins in the right place, it started working correctly. I had this wire right here off, so this sensor was reading a high, keeping that on like that. And it showed high all the time. So once I figured out that I had my wire in the wrong spot, then we got it to work right. But that's things you got to make sure that you get right when you're hooking everything up, to make sure that you got all your pins, all your jumpers going to the right position on your breadboard. Now, this is what we're going for. Now, I got the old sketch in there, and you can see that the lights come on, and then when we cross over the other sensor, the lights will go out. So that's what we're looking for. So we want to determine which end we're starting from, so we could say the other end is the leaving end. So no matter which end we start from, the other one is going to be the leaving end. And the way we're going to do that is with two if statements here. Throughout this sketch, we have a lot of if statements and some nested if statements. So if you remember correctly, whenever the if statement is true, we execute the if statement. If it's false, we just skip past it. So you have to remember that through this entire sketch. If, then we're going to put two parentheses in here, and you'll see why. Digital read and sensor 1, another close parentheses. And when we're in our code, we have to put two equal signs in there to say sensor 1 is low. If we just put one equal sign in, we're just going to say sensor 1 is low all the time. But in this situation, in the if statement, we're saying if it is low instead of determining that it is low. So that's why we have the two equal signs in there. And then we're going to do and another condition, sequence started. Sequence started. Oh, another parentheses in there so you can see that this parentheses and that parentheses match. So we have to put the whole statement in parentheses, and then we'll do the braces, and we'll move the one brace down so we could put some other statements in here. All right, so we're going, now that we've determined that the sensor in 1 is low and the sequence started is 0, we want to change the sequence started. And you'll see in this one we only use one equal sign, and then we're going to say leaving sensor is equal to sensor 2, and then we're going to use our function flash LEDs. Okay, so what we're doing here, now let me explain it. If the sensor that we read, sensor 1, is low, and the sequence started as 0, which means it's false, then we're going to determine sequence started, we're going to change that to true because we're starting the sequence. We're going to change the leaving sensor. We're going to call the leaving sensor number 2, sensor 2, and then we're going to flash the LEDs. So that's the beginning of the first if statement. And we'll move that up a little bit higher there. And we're going to do an identical if statement. So what we're going to, instead of typing all this in, we're going to copy this and make the appropriate changes in there. So we'll make this sensor 2, and this part will stay the same. Sequence started 1, leaving sensor will be sensor 1. So see what we did there? If we're coming from the other direction, we're going to do the same thing. Now these two if statements are independent of each other. So we're going through the loop and we're looking to see which one is true. And if the sensor 1 is true, then we'll continue what's in this if statement right here. Now if this sensor 1 is high, we're just going to ignore everything right here and then come down to this one. Then if sensor 2 is low, we'll start sequence is false, it hasn't started, then we'll change everything here. Sequence started as 1, saying it started, leaving sensor is sensor 1, and then we'll flash the LEDs. So between those two if statements, we're determining which sensor is the starting sensor and which one is the leaving sensor. Now once we determine that, then we have to go through a couple of other if statements to determine what's going on. If, and we'll put this in there. If sequence started, then we want to flash LEDs. And then we're going to do another if statement. If digital read leaving sensor. Now I'll explain that once I type this in. Okay, so we got the braces in there. So we'll give it some room so we could play around with this right here. Now, this second if statement, digital read leaving sensor. So if the leaving sensor is low, so we're waiting for something to go over the leaving sensor. And once that happens and the sequence started is already started, which is equal to 1, this is in conjunction with that first if statement, because the other if statement said if that sensor was low and sequence started as 0, that means nothing started yet. So we're coming from the opposite direction. So what we're saying is here, if the leaving sensor is low, if the locomotive goes over top of the leaving sensor and the sequence is started, it is going to be leaving, and we could shut it off pretty soon. But we're still in this state right here. Now this gets pretty interesting right here, because what we're doing with the code is, you know, we're thinking about what we want to happen, and then we're actually writing it into the code. So we're going over the sensors. We already crossed over the one sensor, and then we just are over top of that other sensor. So once we're over top of that other sensor, we're still flashing the lights. But what happens next is, what happens when the train leaves and nothing's over the sensor anymore. And while this condition is still true, we'll keep flashing it. But once it isn't true anymore, then it's time to say, we're going to shut this thing off, and we're going to shut the LEDs down. The train's already gone. We don't need to flash anymore. So that's what this whole statement is about. So that's what we have to think about beforehand in anything. If we want to have something happen, we have to think it out of what is it that we need to happen, and then once we know what it is that we need to happen, then we could put it into code. We could figure out how to put it into code and play around with it. And what I showed you in some other episodes about the serial monitor, here's where you could test your conditions to see what the condition actually is when you're writing the code. If it's not, you know, if it's not working the way you want to, you could put in that serial print line, see what's going wrong, and that way you could find out where you can correct your sketch. So let's get back to writing this thing right here. Wow. Sequence started is equal to 1, and then we'll put another curly brace in here for the while statement, and put another curly brace in here, and then move this down so we could continue with the while statement here. And we want to put sensor count is 0. And we did a while statement before with the for in there, and we'll do this right here. And what we're saying is, we're going to count once we're in here. And we're doing the I equal 1, and I will say 40 to give it a little bit of time to count, and then we'll increment the I's. And here's where it gets a little bit tricky, because we got to put in another brace. And we got to keep track of these braces. So that's why you put the brace in right away and then move down, so you can keep track of these braces. And so what comes after next in the for statement is what's happening in that for statement. So we're going to put another if statement in here. And if digital read leaving sensor is low, we're going to sequence the counter. So we'll put in the if. Digital read leaving sensor, if it is low, we're going to increment through these values here, the sensor count. So we're going to, as long as I is less than 40, we're going to be okay for this for statement right here. So we're going to delay it for a little bit so it doesn't go flashing by in a jiffy. And we're going to continue to flash the LEDs. The next one is we're going to say what happens after we get through this count of stepping through the 40 numbers. So we'll put in another if statement. If sensor count equals 0, then we're going to say that the sequence started is now 0. So the sequence has on its way the sequence is on its way out. Everything is still in this while statement. So we were checking for two situations, and this last one is whenever the sensor count goes to 0 and the sequence started changes back to 0, so that means it's finished. We're still going to flash the LEDs until we go up to the top again and go through that for integer I equal 1. We're going to count the 40, and then once we're finished with that, then our whole sequence is finished. We'll go out of, so we want to come down here, digital write, LED 1 is low, and digital write LED 2 is low also. Now right there, okay, we'll delete that, bring that up there. We'll auto format it so it makes it look a little bit neater. So we started the sequence in either directions. Okay, so after these, if one of these if statements is satisfied, we come down, if sequence started, flash LEDs. Once that is satisfied, then we go to this one. If read leaving sensor is low, that means there's something over top of it and the sequence is started. Then we'll go through all these steps right here. Now, while sequence started is true and sensor count is 0, then for int, I put two ints in there. For int I equal 1, I is less than 40, I sequence through it. Okay, that's what we want to do. If digital read leaving sensor is low and sensor count, we're going to count through them, delay it, and flash LEDs while we're doing that. We come down to the next if statement, if sensor count is 0. So as long as you have something blocking the LED or the IR sensor, you're okay, it's going to flash. If it's true, we'll do that, and then at the end, when it's false, we'll do digital read LED low, and we're at the end of it. All we have to do now is put that flash LED function in here. We're going to take this from the last sketch that we did, and we're just going to copy it in here because it's the same thing. Void flash LEDs. Now you'll notice that we didn't have to use the extend flashing in this one here. We'll clean this one up a little bit, and we'll see if we have any errors in here. And hopefully we don't have any errors. Okay, expected parentheses. Where were we up here? If so okay, what I did here was I put 2 plus signs instead of equal signs. So let's try this some more and see where we're at. So let's try again. I did the same thing because we copied that. Okay, so good. Since we have the equal signs in there, we'll freshen it up a little bit. Now that we have our sketch compiled, we'll upload it and see what happens here. So we'll come over to here, watch the lights go, and it says done uploading. So this is the one connected to 5, this is the one connected to 6. So we'll hit this one here, and we're not flashing, we're got a solid one. Okay, so there's a problem with it. I wrote something wrong. So we have to go back in there and find what I wrote wrong. Well, that wasn't too bad. It only took me about 5 minutes to come down to here while sequence started, and I have an equal sign in there, and I need 2 equal signs. Hopefully, okay. Let's make sure that that wasn't, no more mistakes syntax-wise in there. Now we'll come back over here and see. And we still have something in the code that is wrong. So let me go back and check it again. Well, I'm looking in the wrong place all the time, and it just dawned on me, maybe I should look back and where I declared everything, and up on the top where I have flash interval, I have as 0. Now that should be 900 like it was in the last sketch that we did. Let's compile this. Well, let's just upload it because it'll compile it by itself, and we'll see what happens here. It's done uploading. Okay, now there's the flash. That's what we were looking for. Finally! Okay. Even I make mistakes. So it's gone past the first sensor, it's over the crossing and covering up the second sensor. Now once it leaves the second sensor, it just shuts off. It steps through that 40, and it goes through the 40 real fast. There's a 30-second millisecond delay between each count. So 3 times 4, so that's 1.2 seconds for it to stay on. So that's our sketch right there. We did it. Now we'll go back this way. And this is the leaving sensor here. And it shuts off. Like always, I'll have the fritzing diagram and the sketch up here. The fritzing diagram and the sketch can be found on tomstrainsandthings.com/Arduino. Sometime in the coming week, I'll have the sketch up there for the arc flashing and show you where I put it on my layout. So we'll see ya.